Recording has started.
Okay, so we left off yesterday talking about converting percents from percents to ratios or the fractional form and percents to rates or the decimal form. Today we want to look at actually performing calculations with our percents. And I had promised you we'd look at two different methods. Those two methods are the ratio or the proportion method and the second one is the rate method. You'll notice I'm leaving the right side of my screen over here blank as we go down through because I'm going to come back and redo each of these problems using the rate method. For now, I'm going to start with the proportion method. And the proportion method looks just like what we were doing yesterday to convert our fractions back into percents. If I had 3/8, we read that as 3 out of 8, and we wanted to convert that to a percent, which is out of 100. And of course, we learned the shortcut to find that missing number, which was to cross multiply and divide. There's two numbers that are diagonal to each other, the 3 and the 100 in this case, those get multiplied. Then the number that's diagonal with our missing number, in this case that's the 8, we divide by that. So I don't know where my 80 came from there, that should be just 300. 300 divided by 8 is 37.5. So 37.5 out of 100 or 37.5% for that. So now let's try to apply that to some generic, at first here, percent problems. We might be asked to find 35% of 48. I find it easiest with these problems if I always start with the percent. 35% is 35 out of 100. Now, before we go any further, let's talk about what those pieces mean in that ratio there, 35 out of 100. The 100 actually represents 100%. Remember, 100% is the whole thing. Or, for percents, we refer to that as the base amount. So the base amount can either be the complete thing, the whole thing, or if we're looking at change over time, it is the starting amount, the beginning amount. Then the 35 represents what we call a portion of interest. Usually just called the portion for short. So it's the piece of that base amount that we are focusing in on with this percent. Now on the other side of our proportion here, the other half, whatever goes on top has to have a link with the 35. Whatever goes on bottom has to have some link with the 100, or the whole amount, the base amount. Well, the way this reads, it says find 35%. That seems to indicate that what we're looking for matches up with the 35. Of 48, we can read that as out of 48, which implies the 48 goes on bottom. And now our process is just like it was up here. We cross, multiply, and divide. So we find the two numbers that are diagonal with each other, in this case the 35 and 48. We multiply. 35 times 48 will give us 1,680. And then the number that is diagonal with our missing number, in this case the 100, is what we divide by. So 1,680 divided by 100 is 16.8. So 16.8 is our 35% of 48. These problems can be worded in a few different ways. We might have blank is 125% of 64. Well, again, I start with the percent. 125% is 125 over 100. On the other side of this, I have to match things up. Well, again, blank is 125. Implies my missing number matches up with the 125. Of 64, again, I could read that as out of 64. Implies that the 64 goes on bottom. And again, I match up, I do the process. I multiply the two numbers that are diagonal with each other. 125 and 64 are diagonal with each other. 125 times 64, what is that, 8,000? Let me double check that. Oops. And it is 8,000. Then we divide by the number that's by itself. So we'll divide by the 100, giving us 80. So 80 is 125% of 64. Now I want to point something out here. The 80 is bigger than the 64. But you remember, this percent is bigger than 100%. 100% means the whole thing. So if we have a percent that's bigger than 100%, that portion that we're focusing on is actually larger than that base amount. We might have 40% of 25 is blank. This one's worded very differently, but it's the exact same type of problem. Percent didn't get it. So we start out with the percent. 40% is 40 over 100. Of 25, again, we can read that as out of 25, implies that 25 goes on bottom. So now we cross multiply and divide. 40 times 25 is 1,000. And we divide by 100 to give us 10. 40% of 25 is 10. Worded very differently, almost backwards, but the exact same process. Well, we might have 32 is 80% of blank. So we're going to start out with the percent again. 80% is 80 out of 100. 32 is 80%. That implies the 32 goes with the 80. Of blank, if we read that as out of blank, implies that missing number goes on bottom. So now you'll see that the missing number's in a different spot in our proportion. But the process, the calculation is still going to be exactly the same. We cross multiply the two numbers that are diagonal, 132 in this case. We multiply those to get 3,200. Then we divide by the number that's diagonal with our missing number. We divide by the 80, which is going to give us 40. 32 is 80% of 40. We might have 20% of blank is 16. Again, we start with the percent. 20% is 20 out of 100. On the other side here, we have of blank. If you read that as out of blank, that implies the missing number goes on bottom. 20% is 16, implies that 16 goes with the 20. And again, we're going to cross, multiply, and divide. We find the two numbers that are diagonal. The 100 and the 16, we multiply those to get 1,600. And the number that's diagonal with the missing number is what we divide by. We'll divide by 20. That gives us 80 there. 1,600 divided by 20 is 80. 20% of 80 is 16. There's another form, one last form we can look at here, and there's something like this. 42 is blank percent of 60. All of our previous examples, I have said to start with the percent. But here we don't have the percent. But it doesn't matter. We can still start with it. Blank percent is just going to be blank out of 100. What we're going to try to find is what that number is over the 100. Equals, now on the other side here it says 42 is blank percent, so 42 matches up with that missing percent. Of 60, again, can be read out of 60, implies that 60 goes on bottom. Now again, we're going to cross multiply, so we find the two numbers, they're diagonal with each other, that's the 142, that multiplies to make 4,200. And we divide by the number that's diagonal with our missing number, the 60. So that 4,200 divided by 60 is 70. 70 out of 100, or 70%. So 42 is 70% of 60. We might have blank percent of 30 is 12. Again, we don't have the percent, so we're going to start out as blank out of 100. Of 30, we can read that as out of 30, so the 30 goes on bottom. Is 12, blank percent is 12, implies the 12 goes with our missing percent. Once again, we can cross multiply. 100 times 12 is 1,200. And we divide by the 30, gives us 40. 40 out of 100, or 40% of 30 is 12. So you can see in each of these problems here, from one type to another, the missing piece was in a different spot. Here the missing piece was there. In this one, the missing piece was on bottom on the right side. And on these, the missing piece was on top on the right side. The missing piece was in a different spot, but the calculation was always cross multiply. Find the two numbers that are diagonal and multiply them. And then divide by the third number. So with the proportion method, the difficulty is really just getting the numbers into the right spot in that proportion. And they kind of line up. They match up. Now, there are some textbooks, some teachers that teach a shortcut. They call it is over of. And for these types of simple little sentence problems like this, it's true. The is the 12, that goes on top. The of is the 30, that goes on bottom. Is over of. But you get into word problems, and that isn't necessarily the case. So you don't want to get hung up on little shortcuts like that, because they don't always hold true. They're not universal once we get into word problems. Well, as promised, we're going to go back and do each of these examples with the rate method. What the rate method involves is converting the percent to a rate. In other words, a decimal. It's decimal form. So for our first one here, we would start out by taking our 35% and converting it 0.35. The rest of the rate method depends on what other piece of information we are given. Here we are given the base amount. If we are given the base amount, we are going to do base times our rate. So that base amount of 48 times the rate of 0.35. And that does give us 16.8. Now that seems really quick and simple, and it kind of is. Let's look at some more examples. This one has a percent of 125%, so we convert 125% into a rate of 1.25. Once again, we have the base amount of 64, so it's 64 times 1.25, which is 80. Again, that seemed pretty quick and simple. Here we have a percent of 40%. Convert that to a rate of 0.4. And even though this problem looks very different, what we were given here, the 25, is still the base. So we take our base of 25 times our rate of 0.4, and that does give us 10. So that was very quick and simple for those examples. But if we look at this next one here, we still have our percent, which is 80%. So we'll convert that into a rate, 0.8. However, what we're given here is not the base. That is the portion. If we're given that portion of interest, what we end up doing is we take the portion divided by our rate. So this would be the portion of 32 divided by 0.8, which is going to give us 40, which is the correct answer, which is what we got up here. But with the rate method, part of the difficulty is you have to be able to identify what it is, the piece of information that you're given. You have to identify what it is and then decide, am I going to multiply by my rate or am I going to divide by my rate? So like this next one, the percent of 20% gives us a rate of 0.2. And we're going to take our portion of 16 divided by 0.2 to get 80 as our base. So there we had to divide. And there's a third type of a problem yet, like this next one, where we're not given the percent, so we can't convert it to a rate. Here we have to find the rate by doing the portion divided by the base. So 42 divided by 60 gives us 0.7. And then that gets converted from a rate back into a percent of 70%. So with that rate method, you have to convert the percent if you're given one, but then you have to decide what information is you're given. Is it the portion or is it the base? And then you got to decide, am I going to divide or am I going to multiply by my rate to get the correct answer? Whereas the proportion method, as we saw, it's always set up in that proportion. You just have to get the numbers in the right spot. And once the numbers are in there, the calculation is always cross, multiply, and divide. There is no deciding, do I multiply or do I divide here? Obviously, I am a little bit partial to that proportion method. I think it's a lot fewer mistakes made in that proportion method. And when we do examples here now in a minute of word problems, we're going to see the word problems are easier to do with that proportion method because there's actual identification to what those numbers mean. There's meaning to those numbers, and that helps us put things in the right spot in that proportion. Now, the rate method does have a place. That rate method is most useful when we know the base and the rate or the percent. And then we're finding the proportion, the portion of interest, because we're just going to simply multiply that base amount by the rate to get that portion of interest. This type of calculation comes up often enough that the rate method does get used quite a bit. Interest calculations, commissions, if you get any sort of sales or any other commission-related jobs, those are a base amount times a rate. So it's very simple to calculate with the rate method. A number of things like that, where you're always going to be given the base amount and a percent, so you can turn it into a rate and do that calculation quickly. But when it comes to problem solving and word problems, where you have other pieces that are missing or that you need to find, typically for me, that proportion method is simpler to do. Let me show you what I mean here. Let's say FML Corporation estimates weekly profit as 8% of gross weekly sales. Find the gross sales for a week where profit is estimated as 277,600. Now here, first thing we want to do in a word problem is, before we start plugging numbers in anywhere, is we want to look at what we have in the problem. When we're dealing with percents, there's either 2 or 3 different values that are given. Here there's 2. There's weekly profit, and there is gross sales. And it helps if we decide which one makes sense to be the base amount, the whole thing, and which one is a portion of that bigger amount. And here, gross sales is the whole amount. Weekly profit is a piece of the gross sales. So the gross sales is everything you sold. That's going to include all your expenses, your overhead, and your profit. Whereas weekly profit is just that one little piece out of the big picture. Now, with that in mind, let's look at the numbers. We have 8% here. 8% is 8 out of 100. Well, we've already said that the base amount is the gross sales. Remember, the 100 in that percent ratio represents the base amount. And the 8 is the portion, which we said was the weekly profit. So now when I set up the other half of my proportion here, I have to make sure that anything I put up here also represents weekly profit, or anything I put down here also represents gross sales. Well, looking at my problem, the only other number I have is the 277,600. What does that represent? Profit or sales? Well, profit is estimated at 277,600. That is an estimate of the profit, so that has to go on top. A lot of people, if they don't break this down and analyze it like that, they just look, oh, 277,600 is a large number. That's got to be the base amount. In this case, it is not. So we cross multiply 100 times 277,600 divided by 8. Gives us 3,470,000 as our gross weekly sales. DBM Corporation estimates labor cost as 12% of total revenue. Estimate the labor cost for a week when total revenue is $620,000. So again, there are two numbers here. There's labor cost and there's total revenue. Again, which one is a piece of the other and which one's the whole thing? Well, the total revenue would be the whole thing. Labor cost is a piece of the total revenue. So when I look at my percent, 12%, 12 out of 100, the total revenue is the whole thing. That's the base amount. The portion is that labor cost. And now on the other side, we have to match up. The number we have is the $620,000. That is total revenue. So that has to go on bottom with the total revenue. And now we'll cross multiply and divide. The two numbers that are diagonal this time are the 12 and the 620,000. So we'll multiply those and then divide by the 100. Give us 74,400 as our estimated labor cost for that week. Sam buys materials for $180 and adds a 9% markup. To the customer. How much is Sam's markup? Now, I worded this question in a very specific way for a reason. Because in this question, there are only two components being used. We have the markup, and then we have the price that Sam buys the materials for, which you could call the cost or the purchase price or whatever you want to call it. The name doesn't matter. It's just keeping it consistent through the problem that matters. That's what Sam purchased it for. That is the base amount. That is the starting amount. Remember, we said the base amount can either be the whole thing or the starting amount. That's the price at the beginning of all this, the $180. So our 9% here, 9 out of 100, the 100 is that cost, that starting amount that Sam paid. The 9% is going to be the markup because it says 9% markup. So it's pretty obvious that the markup goes with the 9%. On the other side, the $180 is the cost. That goes on bottom. And we'll cross, multiply, and divide. 9 times 180 divided by 100 is going to be what? $16.20, I believe. And it is. So Sam's markup is $16.20. So that's what Sam charges the customer for purchasing the materials and transporting them to a job or whatever. Now, slightly different than that problem, Sam buys materials for $320 and adds 9% markup. So kind of a similar setup, a different price, but still the 9% markup. But now the question is, how much does Sam charge the customer? So when we look at this one, we have the 9%. The 9 still represents the markup. The 100, the base amount, is still the cost. We look at what we have here. The 320 is the cost. We can cross multiply and divide. 9 times 320 divided by 100. Is that $28.80, I believe? Double check. It is $28.80. But remember that $28.80 represents the markup. If we look back at the question, that's not what we're being asked for. We're asked, how much does Sam charge the customer? So in this problem, there is a third value. That third value is the charge to the customer. And we would find that by taking the cost and adding the markup. First, we'd have to add a decimal point and fill in some zeros there. $348.80 is what Sam charges the customer. Many times with percent problems, we end up with either what's called a percent increase, which is what this one was, or a percent decrease, which we'll look at in a minute here with discounts. In a percent increase problem, we have some sort of a base amount. We're going to add an increase to it to get a final amount of some sort. And in a percent problem like this, each item is described by 2 numbers. One of those numbers is a percent. Then the other one is an amount of some other form, whether it's a count or, in this case, it's dollars. And the hidden number in here is always that 100%. The base amount is always 100%. So now in this last problem, there was an increase or a markup of 9%, which meant the final amount was actually 100 plus 9, or 109%. So since we knew the base amount, or what Sam had paid for that material, was 320%, or $320, I should say, and what we were looking for was that final amount charged to the customer, we could have skipped over the 9% and actually just used 109%. 109 out of 100 equals blank over 320. Here, if we had cross multiplied and divided, what we would have got here was the $348.80. Now, in a problem like that one, it's just as easy to just find the 9% and add it on. But we can run into problems where we have something like this. After a 6% tax, Pat pays $265 for supplies. How much was the tax? So in this problem here, many people will be tempted to jump in and find 6% of that $265. The problem is that $265 is not the base amount. Again, the words we use here don't matter. It's what they represent. Our base amount we're going to put down here is before tax. We add tax to that, and then we get our price after tax. Again, it's not the words that we use that matter, it's what they represent. We know that the before tax, and we'll put percents on one side again and dollars on the other, that the before tax amount is what we're looking for right here. Well, actually, we're looking for the amount of the tax, but you get the picture. The $265 is the after-tax amount, how much they paid after the tax was added in. The 100% or the base amount, of course, is that starting amount, the before tax, and the tax was 6%. So the after-tax amount, we took 100 plus 6, is 106%. So we could use that to find this before-tax amount. 106% or 106 over 100. Now the 265 and the 106 both represent the after-tax, so they go together. So the 265 goes on top. We cross multiply and divide. 100 times 265 divided by 106 should give us 250, and it does. $250 was our price before tax. Now we can find the tax by subtracting. The difference between 265 and 250 is $15. So that was the amount of the tax. Had we just found 6% of 265, we would have been off by pennies, but we still would have been off. Because that 265 does not represent the base amount. It should not be going with the 100. Notice that's $15.90 tax, not $15, because this does not work. Whatever we put on bottom here, whatever we match up with the 100, has to be the base amount, that initial amount. And in this case, it wasn't. It was after the adjustment was made, is what that 265 represented. We have a similar thing with a percent decrease. Let's say that after a 10% discount, Kelly pays $405. Let's say, what was the price before the discount? Or just say, what was the full price? So again, this is a percent decrease problem. We started setting up the table above. We have an initial amount. In this case, that's the full price. We're going to subtract that decrease. In this case, the decrease is a discount. It could be a markdown for a price reduction or any other thing. And then down here we have the amount paid. And again, each of these items is represented by two numbers. One is a percent, and again, this one is a dollar amount. The $405 represents the amount paid. The full price, though, is the base amount, so that's the 100%, and we have a discount of 10%. Well, we subtract the discount, so we do 100 minus 10, the amount paid is 90%. So what we're really working with here is 90%. The 405 and the 90% both represent the amount paid. The 405 has to go with the 90. And we will cross multiply and divide. So 405 times 100 divided by 90 gives us $450. So $450 was the full price. Now we go back to make sure that answers the question. We were asked what was the full price. So $450 is the answer we're looking at. So when it comes to these percent problems, you have to be very careful. Keep track of what each percent represents so that you make sure you're matching up the correct things in these proportions. That's why I like the proportion method, is because when I set it up like this, I know that whatever this 90% represents has to be the same thing that this dollar amount represents. If they don't represent the same thing, they can't go in the proportion together like that. Okay, I've babbled on long enough. Time for you guys to try these. Your homework in the book, page 84 through 89. 1 through 53, the odds. Now again, I realize some of the simpler ones might be easy for some of you, but make sure you do plenty of the word problems here. The word problems are where people tend to struggle when it comes to percent. Just to give you guys a little bit of a heads up, Unit 2, we were a full week into Unit 2 now, actually a little over a full week into Unit 2. Unit 2 test is 1 week from today on September 24th. So just be prepared for that. It is coming up quickly. Any questions? Okay, I'll let you guys have the last 7 or 8 minutes here to do homework if you'd like. Otherwise,